Normal probability curve is based on simple probability theory. If you have a one coin in hand and you toss the coin, the probability is that either you will get a head or you will get a tail. So the probability of getting a head is 50% and probability of getting a tail is 50%. If you have two coins in hand and you toss the two coins simultaneously, the chances are that both the coins show head or both the coins show tails, or there can be a third possibility that one coin can show head, another can show tail. So you get h square plus 2h2 plus t square. If you simultaneously toss 10 coins, the equation would be something like h raised to power 10 plus 10h to h raised to power 9 t plus 45h raised to power 8 t square and so on and plus t10. You can generalize this if you have two things a plus b raised to power n, then the general equation can be nc0 a raised to power n plus nc1 a raised to power n minus 1 b and continuing up to ncn b raised to power n. Normal probability curve has certain distinct characteristics. The very first characteristic of normal probability curve is it is bilaterally symmetrical. 50% of the cases lie below the midpoint and 50% of the cases lie above the midpoint. It has exactly the symmetrical shape on both the sides. Mean, median, and mode coincide in normal probability curve. They have exactly the same value, and points of inflection are at one standard deviation unit. That means the curve changes its angle at one standard deviation unit. It is asymptomatic. It never touches the x-axis. Another characteristic of normal probability curve is there are fixed number of cases at different standard deviation unit. Mean plus minus 1 sigma covers 68.26% of cases. Mean plus minus 2 sigma covers 95.4% of the cases, and mean plus minus 3 sigma covers 99.7% of the cases. So the total area of the normal probability curve is mean plus minus 3 sigma, that is 6 sigma in nutshell, and it is assumed that 100% cases are covered between mean plus minus 3 sigma. Y ordinate represents the height of the curve, and it can be calculated by the given formula where y is the ordinate, the height of the curve above the horizontal axis, x represents the deviation from the mean, sigma represents the standard deviation, and pi is a constant having a value of 3.14, and e is also a constant with a value of 2.718. There is a relationship between the constant. One probable error is equal to 0.6745 sigma, or in other words, you can say 1 sigma is equal to 1.4826 probable error. Normal probability curve is unimodal. There is only one point where there is concentration of cases, and it is where the mean, median, mode coincides, and it doesn't have two pickedness. as in shown in the bimodal distribution. You can understand the concept of skewness from the normal probability curve. Normal probability curve represents where there is symmetrical distribution of cases around the mean and 50% of the cases lie below the mean and 50% of the cases lie above the mean. In negatively skewed distribution, you can see there is concentration of cases on the positive side. That means above the mean, there are more cases which lie. On the other hand, when we say the distribution of score is positively skewed, that means the number of cases are concentrated on the lower end of the curve. That means more of the cases lie below the mean in the distribution. So you can understand the concept of skewness by comparing the distribution of scores to the normal distribution. The kurtosis refer to the pickedness of the curve. In normal distribution, it is referred to as mesokurtic, and if the pickedness is higher than the normal distribution, then it is referred to as leptokurtic, and if the distribution of score is flatter than the normal distribution, it is referred to as platykurtic. So these are some of the characteristics of normal probability curve, and skewness can be worked out from the mean and median, or it can be worked out from the percentile, and that is P90 and P10 and P50, which represents the median. Kurtosis can be worked out from the quartile deviation, that is Q, then P90 and P10. And skewness thus refers to the distribution of scores around the mean, and kurtosis refers to the pickedness of the curve. There are a number of applications of normal probability curve. Normal probability curve can be used to determine the percentage of cases in normal distribution within given limits. For example, if you know that you would like to find out how many cases lie between mean plus minus 2.5 sigma, then you can go to the table A where you find the number of cases under the area curve, and you can find out how many cases lie between mean plus minus 2.5 sigma. Or if you are interested in how many cases lie between mean plus minus 1.5 sigma, then you can see that you are interested in finding out 50% of the cases lie above the mean and 50% of the cases lie below the mean. So 1.5, the central position, can be taken up, and you can work out the number of cases that lie between mean plus minus 1.5 sigma. Then find the limits in any normal distribution which include a given percentage of cases. If you want to know 75% of the cases lie between what scores, you can use normal probability curve and find out. If you are interested in comparing the two score distributions which are overlapping, that if you are interested in, say, boys and girls, they have shown a performance on a particular test, and you have a large sample of boys and girls, and you would like to find out how many boys actually outperformed the average performance of girls. Or in other words, if you are interested in how many girls outperformed the average of the boys, you can use normal probability curve and find out the number of cases. You can also determine the relative difficulty of questions of a test. So, how many students have passed the various items on a test? You can compare the difficulty level of the various tests by calculating the percentage of cases who have actually been able to pass that item. In addition, if you would like to categorize your students into 5 categories or 3 categories, then you can also use normal probability curve. If you have the mean and the standard deviation, you can find out how many students needs to be given grade A, how many need to be given grade B, or how many can be given grade C if you want to categorize your student on the basis of the performance in 3 categories. Then you can use normal probability curve to decide the number of students who will get A, B, and C grade. So these are some of the applications of normal probability curve.